This next equation that we're trying to find the rectangles for, I'm not going to graph. I'm basically just going to do it by looking at the formula and applying the same thing that I did graphically last time. So I'm going to start by trying to figure out how long are these rectangles, what's the base each time. To do that, I'm going to take the distance in the interval, b minus a, divided by number of rectangles. 6 minus 4 divided by 4 gives me 2 over 4, or 0.5 is the length of each rectangle. So for my left-sided rectangles, I'm going to need to find f of the original point, the left-sided value. Then I'm going to need to find 0.5 beyond that, 0.5 beyond that, 0.5 beyond that, and I stop here because I've gotten to my fourth rectangle. This is going to be my left side. When I go to do my right side, I'm going to start 0.5 beyond my left end point. So here I'm going to start at 4 plus 0.5, or 4.5. Then I'm going to find f of 5, f of 5.5, and finally f of 6. When I add all these together, I'll get my left-sided value. When I add all these together, I'll get my right-sided value. So first we're going to plug in 4. 3 times 4 squared minus 4 times 4 plus 1. I'm going to get out my calculator for this because this is going to get a little tough. So you can put this in as your y equals, then keep doing x values. I don't know if you find that easier or if you just want to plug it in each time. I'm just going to keep plugging it in. So 3 times 4 squared minus 4 times 4 plus 1 gives me 33. If I now do 3 times 4.5 squared minus 4 times 4.5 plus 1, that answer is 43.75. When I do it for 5, 3 times 5 squared minus 4 times 5 plus 1, that gives me 56. When I do it for 5.5, 3 times 5.5 squared minus 4 times 5.5 plus 1. That gives me 69.75. When I add all these together, 33 plus 43.75 plus 56 plus 69.75, I get a total of 202.5, which is the correct answer for the left-sided rectangles of this equation between 4 and 6. Oh, I'm sorry, I did do something wrong here. Here I just took the y values. I forgot that I have to see that their x distance as a base is 0.5, not 1. So I really should have been multiplying each of these times 0.5. Really, that would just mean that I multiply my final answer, 202.5 times 0.5, which would give me 101.25. That's the actual correct answer. But let me go back and correct these. 33 times 0.5 gives me 16.5. 43.75 times 0.5 gives me 21.875. 56 times 0.5 gives me 28. And 69.75 times 0.5 gives me 34.875. So these are what I'm actually supposed to be adding to get to here. Let me just double check that it does. 16.5 plus 21.875 plus 28 plus 34.875 does in fact get me to 101.25. So apologies again, to be clear what I messed up. These are the y values, or in other words, the heights of the rectangles. But to find the area of a rectangle, I need to do height times base. Since we found we're moving 0.5 in the x direction each time, I really need to multiply by those bases to find the actual areas of the rectangles. That said, when we move on to do the right side, we've done most of the work already. We know that when we did 4.5 above, we got an area of a rectangle where the rectangle was 21.875. Same thing for 5, we already got 28. And for 5.5, we already got 34.875. Only thing we need to do is calculate for 6. 3 times 6 squared minus 4 times 6 plus 1. When I put that into my calculator, that gives me 85. Again, I need to remember that's the height of the rectangle. To find the area of the rectangle, I multiply that by 0.5. 80 times 0.5 gives me 42.5. Now I can add all these areas of rectangles together to get the total area. When I do that, 21.875 plus 28 plus 34.875 plus 42.5 gets me to my final answer of 127.25. So from the left side, the area is found to be 101.25. From the right side, it's found to be 127.25. We know the real answer is somewhere in between, but again, adding up by rectangles here is an inexact science where we're either going to overestimate or underestimate. It's really building towards us understanding how to use integration.